All right, let's get started. So we're talking about Jest, getting started with testing. So let's talk about what testing frameworks kind of are all about. So a test runner, which is what Jest is, contains tests, which are sometimes also called specs. Each one, that is, each test sets up the app, does something, verifies the expected thing happened. If the expected thing doesn't happen, it throws an error. So a test runner is something that contains like setup, do something, verification code. If any of it throws an error, it reports that back to you. You could say it reports back all errors. Ta-da! Popular test runners for JavaScript. Jest is by far the biggest one right now. It was heavily inspired by one called Mocha. There's also one called Jasmine. There's also one called JS Unit. There's also one called Karma. All of them do the exact same thing. Most of them have different syntax for writing the tests. Some of them will include more or fewer things that do this verification. For example, Jest is batteries included, so it comes with like expect, and you can do all those assertions and stuff with it. Like expect this to be, expect this to match, all that sort of stuff. Other libraries like Mocha doesn't include any of that. So you'll like install a different library called an assertion library, and its only job is to throw these errors. Expect, for example, is an assertion library. Just happens to include it. But that's all a test runner does. You write these specs. Each spec sets up the app, does something, makes an assertion about that. And if the assertion isn't true, throws an error, shows you all the errors that happened. Before I move on, questions about test runners?
Is that the same thing as the NPM test?
NPM test is a way to run a test script with NPM. So check this out. Okay, so nothing up this sleeve, nothing up this sleeve. If I make an NPM project, in this package.json file that it made, which is the only thing that init command did, all it did was just make this file and pre-populate it with some stuff. So if I take a look in here, it has this test script. If I run npm test, by default, it just prints all this out to the screen. It'll say error, no test specified, and then it'll quit. Let's see if that's right. npm test. Error, no test specified. So it just runs any kind of bash script that you put in there. Interesting. So if we installed jest, oops, npm install jest, and I changed that test script from the echo command to jest, now npm test runs jest. So I changed that to jest. Now, when I run npm test, that's a jest error. It said it couldn't find any tests because I haven't written any. That's all that's happening there.
Thank you.
Other questions about test runners? Cool. All right. Your turn. Follow along with me. I'm going to delete all this stuff. All right. Nothing in this folder. Get yourself on the command line over to some kind of empty folder. Next, we're going to initialize that as a node project. npm init-y. If you leave the y off, it just prompts you for what each of those values should be. We don't care. So that just gives you all the defaults and creates that file. Next step, npm install, or npm I and npm install are the same command. Jest. It's like test, but with a J.
Do you have to install Jest with each project that you do?
With every single project.
Okay.
Because, like I said, there's like 5 or 6 of these things. All of them, you have a bunch of different projects. They might all use different testing frameworks. And since we want to do this collaboratively, I want you to be able to fork and clone my repo and then use the test that I wrote, regardless of whether or not you have it installed. So that's why we do it in the project level rather than like for your computer.
And what does that run npm fund for details mean?
It says 28 packages are looking for funding. It's a relatively new feature that NPM added to where like open source maintainers can say, hey, I give you Jest for free. I wouldn't hate being paid for it though. So if you find it valuable, you could give us some money. Now, I imagine Jest is not one of those because Jest is a product of Facebook. So I doubt that they're begging for open source contributions. But they probably have dependencies that are. So if I run npm fund,
I'm sure that there's a developer somewhere in the bottom basement of Facebook that is totally looking for funds.
So all of these projects are looking for funding. So like rimraf and glob. So those are like super low level command line utilities. Rimraf does rm-rf, but you can run it from JavaScript. That's all that it does. But I'm guessing Isaac S. has a bunch of these kinds of projects and wouldn't mind getting paid for them. There you go, principal engineer at GitHub. Has 17 sponsors.
Interesting.
So that's
Kyle,
one of the
why
ways
did
you can make
yours
your
get-
software free and still get paid for it.
When you did your install Jest, why did it give you like a warn for a bad engine?
Because of the version of Node that I'm using is not technically supported. It still works, but it doesn't like that I'm on Node 16.6. Yeah. So you don't have to follow along with me, but if I switch over to 18, then and then delete all this, I'll bet I don't get the error because 18 I think is a long-term support version. So if I initialize that and then npm install Jest, no errors. Good question. Other questions about test runners so far? Okay, give me a thumbs up if you're caught up. Up, 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 up. John, you okay?
I missed the start. I literally just jumped in, so I have no idea what we're doing right now.
Go to an empty folder, npm init y, npm install Jest. That's all we've done.
Okay, perfect.
Okay, so now let's go into the package JSON file in your text editor. And we're going to change this test script to be Jest. We could also npx Jest. That does the same thing. But most Node projects should have a testing script. That's one of the reasons it's like a special kind of privileged keyword. So let's tell it where to find it. All you got to do is change that script to Jest. And then if you run npm test, you should see that error.
Does Just need to be in quotation marks?
It needs to be in double quotes specifically.
Double quotes. Okay.
JSON is fussy about this. So, and JavaScript doesn't care about using single quotes or double quotes for strings or backticks. JSON absolutely does. So your keys always need to be in double quotes. Any of your string values need to be in double quotes. And cannot use trailing commas. That's an error also. Trailing comma is like last item on a list. Putting a comma there. That's like not even just allowed. It's like a good practice in JavaScript. Not allowed in JSON. Cool. So let's give it a test. If I make a file called, I'm going to call it practice.test.js, like that. Now if I run npm test, it found the file, but it goes, hey, that doesn't actually contain any tests in it. And true story, it doesn't. So if I open up practice.test.js, I can make a test. It's just a function. It's built into Jest. All right, just practicing. That's string. Then the second argument is going to be a function. And we're going to do the simplest possible test we can, which is expect true to be true. And if I do that and run the test, I see fields of green, red roses too. So I get a green check mark and I get the name of the test there. And check it out. If I changed that to be false, that line of code is going to throw an error. And that's what a test runner is. It's something that reports back everything that throws an error. So if I do that, run the test, so this was what I passed in. It was expecting it to be false, but it actually got true. So that's how you would read that error. Regex, name of the test. This is precisely why it failed. This was the part of the test where it failed, was that call right there.
Mine failed me on my first line, and it's telling me that my first double quote is the problem, but
Let's take a look.
oh, yeah. Can you guys see this okay?
Mm-hmm. Beautiful. Missing second argument. It must be a callback function. Who can spot the error?
Too many parentheses.
Too many parentheses. Like parentheses just in the wrong place. But
That's
take a
good.
look at that test. You open the paren, you pass in a string, and then you close that paren. So that's that other thing isn't a second argument. It's like another statement.
Oh, so I was supposed to take this parenthesis
Yeah.
off then?
Test accepts two things: a string and a function. You're only passing in a string to test.
There we go. Okay.
Metal. All right. Anybody else having trouble so far?
I just noticed that autocomplete in Visual Studio really hates the syntax. Like if I try to do test, it changes it. Is that
Check something.
common?
Maybe. Why don't you screen share and let's take a look.
Let's see. So I was just kind of typing it over and to see what happens here, and didn't do it that time. But if I hit my space bar, it felt like it was trying to do test decoder and syntax like that.
Gotcha. It's because it doesn't know that test and expect are injected into the environment by Jest. And so it doesn't think those are valid things. So it doesn't know that you can autocomplete them because you're not importing those at all. They're just injected into the environment by Jest. A way you can get around that is if you put an import statement up there. Oh, shoot, we're in Node, though. Do const. And then we're going to destructure out test and expect.
Be test and expect.
And then set that equal to require jest. And requires a function, so you got to pass that string in.
I see.
All right, let's see if it maybe doesn't get so mad this time.
Yeah, there we
Hey!
go.
And
Awesome.
let's make sure too, since require is dynamic, it won't tell you if there isn't a test and expect export on Jest. So try running your test now and let's see what happens.
Okay.
So that parenthesis after just practicing, you have to move it to the curly brace. It's the parenthesis problem we just had.
Oh, yep,
Oh.
correct.
After just practicing.
Yeah, you're closing the function there.
Oh, I see. And then, bam.
All right, now try running that test. Test is not a function. It might be in a subdirectory. Let me take a look real quick. That was what I wanted to check that. Import test and expect from Jest. Yep. Nope, that's not doing it. I'm going to say require. I'll take a look into it. For now, like, just accept that your audio autocomplete is not going to get those two especially well, but otherwise you'll be fine. Any other issues with getting that first test to run?
Mine says no test. No test found existing with code 1.
All right. So did you, why don't you screen share and let's take a look. What did you name the file?
Practice test.
Let's take a look.
Let's see. Hold on. Let me figure out where my screens are. Screen 2, right there. Share. That's no test.
All right. And so give me an LS. You see it?
You're one letter off, Tiffany.
I am. It's text.
Yeah. So Jest works off of what the file names are. So they have to end in either .test.js or .spec.js.
Okay.
Oh, use your tab
Thank
complete.
you.
Use your tab complete.
I will.
All right. Cool. Any other issues with getting that first test running? All right. So anatomy of a Jest test. This is an assertion. Expect is a function that takes in a value that we want to make some kind of assertion about. Can be any expression. Who's read some of the testing material and can tell me what to be is?
I'm not done there yet.
I read
It's
it.
a matcher.
Yeah, it's a matcher, the most simple one.
Excellent. Brad, tell me what a matcher is.
It matches what is passed into it to what's expected.
Absolutely. So you can live your whole testing life just using to equal. There is absolutely nothing wrong with doing that. And we can use that for just about anything. So for example, if we had an array, I could expect some array dot length to equal 3. And if I run that, hey, I got green check mark. This is where testing philosophy starts getting a little bit trickier than this. I don't want to do this because I want these assertions to have as little logic or room for error as possible. So what you actually do is you say, I want some array to have length 3. Like that. There's probably, I don't know, 50 of these kinds of matchers that do all of these kinds of things. Assert that an object has a property. Assert that an object has a property that has a particular value. Assert that an array contains a particular element. Assert that a certain substring is inside of another string. The first thing you have to learn as a tester is to use those matchers instead of just getting the value and then trying to do like a is equal or equal to about that value. So the full list of matchers that I think you're most likely to use, I have in the curriculum. It is matchers. So all of these matchers, I think you can probably make it through the rest of this program only using these matchers. Got to be, to equal, to be truthy, to be falsy. So those are like our basic ones. With strings, either matches a pattern or contains some substring. Arrays, how long is it? Does it have some thing? Is it equal to another array? Is it equal to another array that has objects? Does it have a property? Does it look like another object? Does it have the same values as another object? And that's it. It's really not that many. It seems like a lot, and it feels like the words they use are kind of arbitrary. I don't even think it's worth memorizing them. Just use a guide like this when you're writing your assertions, and you'll get the hang of it mighty quick. And then lastly, if we have promises, we can say that the promise resolves or rejects to something, or we can invert a matcher by putting not in front of it. So you could say like, I don't know how many this has as long as it's not 3. But that's matchers. This could be expect name to contain Kyle. Passes.
Can you pass multiple things into that, like Kyle or Kyle lowercase, or like
Sure.
anything like that?
So if you wanted to do that, that's when you'd write a regex. So I don't want to get too deep into regex because it's kind of complicated. But regex is pattern matching. And it looks like this. So if I do that, you notice that that's not in single quotes, and it's not in double quotes, and it's not in backticks. It's in between slashes. That's a regex. And if I put an I next to it, that means do it case insensitive. So if I do that, I don't care if it's uppercase K or lowercase k. That'll match. But like that one also will match that, which maybe I want, maybe I don't want. But that'll do a case insensitive match. If I want it to only be the K, then like this is a whole language. So I can say that says either uppercase K or lowercase k followed by YLE. And that one will pass, but if I also make it capital Y, it won't. And like this is one of the reasons that you use these matchers, is it makes these errors so much more descriptive. I was expecting something with this pattern, but I got this string which doesn't match that pattern. Now another thing you could, so like, yeah, you could do it that way. Yeah, that's how you would do that. Other questions about matchers?
Is there anything, you know, we use the dot not to do the reverse. Is there anything else besides that, or is that really the only one that functions like that?
Also the promise ones. So like.
Okay. With the resolves and rejects.
Exactly. So if I.
Okay,
have,
so those are the three that are those chainers.
Yep.
Okay.
Other questions about matchers? All right, let's test some code. So in this same file, I want you to make a function called add that takes in two numbers and returns their sum. So then you're going to make a new test. And for our description, we're going to say what it does, like the thing that we're testing. So like add sums to positive integers. Like that. Now we're going to do these 3 steps. Setting up the app, doing something, and verifying that the expected thing happened. I'm going to stretch this out a little bit, but just barely. Tests are way more verbose, and you have a lot more repetition in them than you do production code. Because your tests are also your documentation. So it pays to be a lot more repetitive than it does in production code. So we're going to have like positive integer 1 is 2. That's 3. So that's our test setup. That's our arrange. That's our given. Now we're going to do something. So this is our act. We'll say the sum is add positive integer 1, positive integer 2. Then we're going to do our verification, our assertion, our then. So this is expect sum to be 5. Now, pro tip on testing philosophy, when you're writing a test like this, start with a false one, because we want to prevent false positives. So do something you know is going to be wrong. If this test passes, that means that this code does not do what you think it does. We want that to fail. So let's see it fail first. Expected 4, got 5. Okay, so that gives me some confidence that like I didn't just bullshit this test and like I'm actually still asserting that true equals true or something like that. So then I can confidently change that to be the right number. And now I should have passing tests.
Why does the test specify 2 positive integers when the function doesn't do that at all?
Because we're not saying everything that add does. What we're doing is specifying that it at least does this. So you could also have a test case that's like add sums to negative integers. So if I keep that the same so I can see it fail, there it is. First one still passes, second one not so much. I change that to be negative 5. Now I have 2 passing tests. So we want both of these to be things that describe what add does. They're not necessarily comprehensive descriptions of what add does, but if I look at these running in that test, all right, what does add do? Well, sums to positive integers, sums to negative integers. So those are 2 equivalence partitions that we're testing.
Didn't you show us at one point writing an add function like this can cause a problem with JavaScript, and thus, you could run this test and show that your function doesn't actually work?
Yes! Let's see exactly where I'm going with this. We could use this to find out that add sums to floating point values. So if I do 0.1 and 0.2, why, I would sure expect that to be 0.3, would I not? The test framework caught it so that we don't have to. So then I can go, okay, well, how do I fix that? Well, one way to do it would be do A times 1,000 plus B times 1,000 divided by 1,000. So now it's going to be 100 plus 200, and then we divide that by 1,000. Three green check marks. Feedback loop. That's a tight feedback loop. That's a lot easier than just like printing console logs and shit all the time. And if I go back to what I had before, check out what the test results look like. It does this, because it has a green check mark. It does this. It doesn't do this. And then we get details about why it doesn't do that. If you've read the test organization stuff, you may have picked up on, we could also wrap this all in describe. We call that add. And then put all of these test cases inside of this. And then we can drop the word add from those. So if I just do that, look what changes in the test output. Add. Does this, doesn't do this. That's pretty slick. You can even change that in your source code. Instead of writing test, hey, now it reads like a little story because it's our documentation. Describe add. Well, it sums two positive integers. It sums two negative integers. It sums two floating point values. That's the BDD describe it syntax. It's not actually any different. It did the exact same thing when this was test instead of it. There's another word for this one too called context. They're synonyms, mean the exact same thing. It's just whichever one makes your test read better.
Can you show us setting up just watch? For whatever reason, when I tried to do it, I wasn't able to, but it was really nice on the when going through the simple unit testing. As I wrote it, it spit out the answer and said fail every time I saved my file.
Wahahaha. Sure. So to do this in watch mode, get a second terminal. So, oh, actually, no, I don't want to do it that way. Do it this way. Okay, so if I want to do this in watch mode, I could say, so the thing that doesn't work is doing npm test -- watch all. Oh no, it didn't keep the thing. If you want to do it that way, you have to put two more dashes and a space in between them. That'll do it. Or an even better way to do it than that is to add another script for that. So like, I'll do that and then add the watch all to just as a separate script. Now, test : watch is not a keyword, so you have to use the run. I can't do npm test watch. I have to do npm run test watch. But now it's going to keep those tests running And anytime I change the code, it'll rerun them too. So if I go, oh, psych, I can make that pass. This is times 10 and times 10 and divided by 10. And like, it'll automatically rerun those without me like having to type it out.
Perfect. I think I wasn't calling the just :run, so that's why I think it wasn't.
So one more time, that script is this.
Or test watch, yeah.
What do you put in the command line to get it to run?
So to run this one would be npm test. To run this one would be npm run test watch. Like that. The colon in this is not special. It's just a character. It's pretty common when you have scripts that kind of build on each other or like different categories. Lots of folks do it, but it's just a character. And so like for the LMS, the ones that I have,
When you're coding and putting in your test, are you doing watch all, or are you just setting it up and then going back? Okay.
Definitely. This one does it automatically, but my API one I had to write out. Yeah. So on this one, I'm doing watch all, but you want, you need at least one of them that doesn't do that, because like, so like this is a safety guard for if my tests don't pass, I don't want it to deploy. And so when I push this up to GitHub, one of the things it does is run my tests. And if those come back without throwing an error, it deploys the site. If it does throw an error, it goes, sorry, buddy. No can will. So if I have it run my watch all command, it'll never stop running the test, so it'll never pass. So I have one that doesn't do that and one that does.
And when you write your test, are you doing it with the BDD or whatever the descriptive terms, or no?
Man, that's a tough one. I used to. I still do it every once in a while, but I actually got talked out of it by super influential testing guy named Kent C. Dodds. There was one of his things that I wrote, or that one of his things that I read that made a pretty damn good case for why you shouldn't do that. And so the example that he gives is this. So it's a hierarchy of describes, each of which has like some before each kind of stuff. And then like each of the actual tests are as little as possible. And like that's pretty common. If you just look at test like out in the wild, it's probably how Ford does it. You look at stuff on GitHub, they're mostly kind of like this, where like you just, because you can nest these inside of each other, so it's like a hierarchy. You'd read this like, when the username is not provided and when the button is clicked, then it should show an error message. The problem is that if I want to figure out what's wrong with this test, I need to go, okay, well, what was actually happening? Well, these things happened first. And then there's this thing that happens to be in scope. And also, this was run before any of that. And all of this stuff up here happened before all of that. It ends up being a ton of reading to figure out why a test failed. And so instead, if you extract all that stuff out, you end up with tons of repeated code. But if this test fails, I know exactly what happened leading up to that. And I don't have to jump all over the file, or God forbid, multiple files to figure out why. So I kind of fell back in love with just using test. I still do before it or describe in it every once in a while, especially if it's just one layer deep. That's all right. But I also try to not do this quite as much as I used to.